Alright, so this is a quick video on a super quick and easy way to tell how a circuit is going to behave as a filter, right? And a filter basically lets some frequencies pass and blocks others. The two kinds that, we're mostly familiar with are a low pass, and over here we can just see this axis is frequency, and the inputs are all sine waves at whatever frequency this happens to be. And usually the amplitude is 1, right? So looking at this blue line, that's what we would call a magnitude. And the higher it is, the more signal is passed through at a particular frequency than if it's lower. So in this case, up to this breakpoint, it's passing the frequencies, equally, and then as frequency is increased, it's blocking more and more high frequencies. So it's called a low pass. And so for a high pass, right, it's the opposite. At lower frequencies, it's blocking and allowing the higher frequencies through. Now there's other kinds of filters, band pass, where it blocks low and high and lets through some in the middle, and notch or band stop, where it lets the high and the low and blocks something in the middle, right? So really, we're just going to find 2 points on this curve, very close to zero frequency and infinite frequency. And if it's high then low in terms of frequency, it'll be a low pass. If it's low then passes the high, it'll be high. So let's just do an example here of an RC circuit, right? And I'm not even going to write the transfer function. I'm just going to use impedance. So the impedance of a resistor is just R, and the impedance of a capacitor is 1 over SC. Now, when we're doing Fourier analysis, we let that equal to j omega, which is j 2 pi f. That's the input frequency that we're talking about. So what happens if we just set f equal to 0, which would be DC? And that would be over here on the left-hand side, right? Well, the resistor doesn't change with frequency, so it's just R, but the capacitance goes to infinity, or an open circuit. So if you redraw that over here, okay, we take it out. Well, there's no current drop, right? So that means with no current drop, VR is equal to 0, and so that means V2 is equal to V1. So at low frequencies, it's passing whatever the input is, right? Now let's take it to, what if the frequency is infinity, right, or close to infinity? R is still R, but notice ZC, 1 over SC, is close to 0. That's a short, right? So I just take this node here and draw a wire, and now ground and 2 are the same. So that's, effectively 0. So here, we're starting off high and ending up low as we increase frequency. That makes it a low pass, right? And yeah, you could do voltage division in the impedance, right? ZC divided by the sum of the impedance of the resistor and the capacitor. And you would get this function here. And yeah, if you just, again, we're not using complex math here, but if S equals 0, this goes to 1. If S goes to infinity, this trends towards 0. So that's the low pass. Now we're going to really speed up. Here's a high pass filter. What happens at 0? Well, I'm not going to worry about the resistor anymore because an ideal resistor doesn't change with frequency. So the capacitance goes to infinity, right? And we redraw it over here. It's not there. So this node 2 is just hanging, but it's connected through a resistor to ground. There's no current, no voltage drop, so 2 is equal to ground. It's 0. Now we let this equal to infinity. We just draw a short. Where now node 1 is equal to node 2. Bam, it's high. So we're getting this. Now we're just taking these 2 points, and I'm just drawing kind of a classic high-pass filter, right? From voltage division, we get a different equation here, all right? Now you don't really need to do these problems. All you have to do is at low frequencies, what is it's the capacitor or inductor an open or a short? At high frequencies, is the capacitor open or a short, or the inductor open or short? So in summary though, right, ZL, that's just S times L, and that's 0 if the frequency is 0, and it's infinity if the frequency is infinity, right? The capacitor we just did, and notice they're opposite, and the resistor never changes, right? So really, if you're shorting to ground, right, an inductor tied to ground at an infinite frequency, no, at 0 frequency is a short, right? And, really, that's all you need to know. Now, yeah, there's some questions where you have a capacitor voltage divided with another capacitor. And the thing is there might be a ratio, right? But that ratio wouldn't change with frequency. Same with inductors, right? But all you got to do is take a look at your circuit, let F equal 0, right? Take out all the capacitors because they go to infinity. When F is 0, replace every inductor with a wire and keep the resistors there. Find out what V out is, right? And then look at high frequencies, right? Replace the capacitor with a short and an inductor with an open. Write out what V out is. So V out is higher at 0 frequency than it is at high frequencies. It's a low pass. If it's higher at high frequencies than it is at low frequencies, it's a high pass. There's a wide variety of these problems, but with that information right there, you should be able to figure out anything.